Okay. Hello and welcome to this Efficiency for Access Design Challenge 2023 to 2024 webinar. Today we'll be talking about life cycle assessment with our fantastic speaker, Stuart Walker. So welcome. I just have a bit of housekeeping to start us off. This session is being recorded, as you've probably seen. So if you don't want to be recorded, please keep your camera off and stay on mute. And you can pop any questions or comments you have in the chat throughout and we can pick those up. We will have a Q&A section in the webinar, so hopefully you have some questions prepared. You're welcome to come off mute, turn your camera on if you're comfortable at that time to ask them. And the slides and the recording will be available on CrowdSolve after the webinar today. If you want to find those, you need to go to the events forum and then find the post about this lifecycle assessment webinar. Scroll down to the bottom and they will be there for you. And finally, I'm joined by Sean today. I think you all know Sean. He is going to be monitoring the chat. So if you have any questions, if you need anything, just reach out to him there and he'll be able to help you. Okay, so let's get started. On the agenda today, I'm going to talk briefly about the relevance of life cycle assessment to the challenge, in particular, the challenge assessment criteria. I'll introduce our contributors today, Stuart Walker and Victor Torres, and we will then go on to Stuart's presentation. We will have a Q&A, and hopefully that can be led by you guys. So if you haven't already, have a think throughout about some questions that you might want to ask, and it would be great if we can kind of delve into the relevance of this topic to your own projects and the wider challenge as well. There's a few notes on the challenge from me towards the end of upcoming events and so on. And then I think perhaps after the end of the session, if you're able to stick around a little bit, we might do some brainstorming on the Students' Choice webinar, which is coming up in March. Yeah, so we've got a packed agenda. Let's make a start. So you're all familiar, I think, with the assessment criteria for the challenge. They are innovation, sustainability, social impact, and scalability. So it's probably no surprise to you that sustainability is the most kind of relevant assessment criteria to life cycle assessment. So the brief asks you, is your design reducing the environmental impact throughout its life cycle compared to existing alternatives? And life cycle assessment is really helpful in helping us understand that the impact of designs throughout their life cycle, those keywords there that you see in the question, it goes beyond what might initially come to mind about the energy source and the purpose of a design and so on. So it can offer some really valuable insights to address that question. It can also be relevant to the question about sustainable development goals. So the assessment criteria ask you how you've addressed those. The obvious one, Sustainable Development Goal 7, affordable and clean energy. You should all be addressing that because of the scope of the challenge, but life cycle assessment can help us address others as well and kind of see those linkages. For example, with Sustainable Development Goal 12 for responsible consumption and production. And then it does go beyond sustainability criteria as well to social impact, because your designs have social as well as environmental impact. And it can also touch on innovation by kind of helping us to like prompting that innovative thinking in response to challenges that might be revealed by life cycle assessment. So that's just a little bit from me. We have a question for you now. So I'm just going to share the whiteboard. So can you see this whiteboard, everyone? Yeah, I'll take that as a yes. So we've got the question for you. Do you plan on using life cycle assessment in your challenge project? So we have a bunch of sticky notes here. If you want to just move one over to the answer that applies to you, that would be great. So to do that on a desktop, you just want to click on a sticky note and drag it across. Or if you're on a mobile device, you can, I think, click on it to highlight it and then click and drag to move it. So hopefully you can all see that and move a sticky note. But if you're having trouble with it, feel free to come off mute and answer, or pop your answer in the chat. That's fine too. I'll just give you a few moments to do that. What are we thinking? Do we think that you are planning to use life cycle assessment in your project? Maybe you're here to find out. I see a sticky note has moved a little bit. Aha, we have a yes. Fantastic. A yes and a here to find out. Wonderful. That's what we like to hear. Great. I think today's session will be really helpful if you're here to find out, and of course, if you're planning on using it. So you're in the right place. Let's move back to the presentation. Thanks for that. Okay. So that was our question, and time to meet our contributors. We have Stuart as our speaker today. Welcome, Stuart. Stuart Walker is a senior consultant at Energy Saving Trust. He has a PhD in renewable energy and now specialises in sustainability assessment of organisations and products, including emissions monitoring, net zero plan development, and life cycle assessment. So Stuart has worked on diverse projects, including developing bio-based blades for tidal steam stream turbines, decarbonisation strategies for small businesses, and assessing the environmental impact of healthcare in the Gambia. And Stuart currently works with Solar Cooling Energy on the development of a net zero cold room. So welcome, Stuart. Thanks for being here. And that mention of the net zero cold room brings us nicely on to our second contributor, Victor Torres, whom Stuart works quite closely with. Victor isn't with us today, but he's kindly shared a talk with us that has some great insights into life cycle assessment and its impacts on design, which we think will be really helpful. And Stuart has very kindly integrated that into his presentation. So let me just introduce Victor to you. He finished his degree in mechanical engineering in Spain in 2004 and moved to Germany, where he worked at the Mercedes-Benz Research and Development Center for 8 years. In 2012, he joined the Institute of Agricultural Engineering at the University of Hohenheim as a researcher and lecturer for solar energy and refrigeration. He finished his PhD studies on solar cooling in 2017 after having coordinated several research projects, mainly in cooperation with African institutions. And then that takes us to 2018 when he founded the company Solar Cooling Engineering, which has developed cooling solutions suitable for local manufacturing with a focus on agri-food value chains. Victor is specialised in the design of cooling systems, specifically considering economical and environmental aspects. He supports field testing projects and is involved in capacity building activities to raise awareness on the potential of local manufacturing. So that's our contributors for today. Thank you very much both, and a very warm welcome to Stuart. I will hand over to you now, Stuart, for your presentation. Thank you.
Great, thank you, Rachel. So here. Okay, so I will now begin my presentation. So I'm going to talk a bit about as Richard's introduced, about life cycle assessment. Victor will sort of join us later on virtually through some videos, but I'm going to kind of talk about two sort of sections really. So first of all, I'm going to kind of introduce kind of probably the overarching principle that that life cycle assessment sits under. So we're going to talk about life cycle thinking and kind of how how even if we're not using life cycle assessment in a kind of software and assessing something in a certain way, we can still apply these kind of techniques and think about our design in a life cycle way. And then part two, I kind of got a case study really. So talking about with solar cooling engineering and with Victor and the people who are helping us develop the net zero cold room, and looking at how life cycle assessment has been applied there and how it's kind of helped us design that cold room. So hopefully it's useful. And yeah, look forward to answering any questions after that. So first of all, I'll talk a little bit about kind of life cycle thinking and what we mean by that. So first of all, if we talk about a life cycle, so what is a life cycle? So it's basically, you can see the kind of example with the caterpillar and the butterfly. It's something that it's the stages of life that anything goes through. So whether that be a product or an animal, as we can see here. So if we think about it in a product sense, it's taking some raw materials, making them into something that becomes a product, then that product is used, and then that product is disposed of, and then that becomes waste or whatever it does at the end of its life. That's its life cycle. So if we try to incorporate life cycle thinking, it's a way of thinking about that whole process throughout the design process. So thinking about that whole life cycle throughout the design process. So when we look to make our product, it's not just thinking about how we can use those raw materials to make it. It's about thinking, if we use certain raw materials to make it, if we make it in a certain way, how will that then affect the later stages of the life cycle? So how will that then be, for example, if we make something from a mixture of materials that are very sort of amalgamated together in a way that makes them very difficult to separate, then that has an impact at the end of life when we try to dispose and recycle those materials. If they're very hard to get apart, then it means that product maybe can't be recycled as effectively as it could be. Or if we make a product with a replaceable part of it, or a part like a filter or something like that that's going to need replacing in time, if we bury that filter right down in the middle of the product where it's really hard to get at, then that means we're not really incorporating life cycle thinking there, because then we're making it very difficult for the later stages of the life cycle to occur. So it's about kind of thinking about all the stages as early as we can. That's kind of the principle of life cycle thinking. So I've got a kind of a bit of a diagram here. So it's not thinking about it in this kind of linear way about having an idea, designing a product, then looking at what to make it out of, and then later on deciding how to use it and how to do the end of life treatment. It's more about thinking about having the idea and then thinking about how we want the product to be used and what's going to happen at its end of life and everything, and then designing it kind of at the same time, and then using all those as inputs to decide what to make it out of and how to make it. And kind of, you can see the arrow kind of looping back to talk about how we use the we come back to that use and end of life question while we're looking at our product design or our materials and manufacture. So that's kind of the overall kind of idea of life cycle thinking. So life cycle assessment is what we're here to talk about today. So that's is a way to understand the environmental impact of a product. So it's a way to understand what the impact of something we make or something we do is. So I'll talk about that again in a second. So I've said it's a way to understand the environmental impact. It can also be used to understand other impacts, so we can talk about that later if people have questions. You can also use it to look at social impacts, and it can be used to look at kind of economic benefits and linked to business models and things as well. And I also said it's the impact of a product. It's not only of a product. We can also use it to look at organizations or businesses or anything like that. But I think most of the time today, we're going to be talking about life cycle assessment, so LCA, as a tool to understand the environmental impact of a product. Yes, I've said that. So most often it's a way to understand the impact that the product has. So we talked about the word impact a few times. So I'm just going to kind of talk about what we mean by that in an LCA context. Sorry, my line's gone in the wrong place there. Yeah, so when we say impact, we mean the change that something causes compared to the world before it or to the world without it. So some examples of that might be if we make a product and it causes if it uses some energy to make a product, then that causes the release of some greenhouse gases from the energy use. So that would be an impact that our product had. If our product is made from, I don't know, say cotton or something like that, then or something to do with soy, something like that, for example, then there's some land use link to how that product is made, and then we can kind of delve into that land use and say what caused that land use, what was the land used before, as deforestation or something like that, for example. And then we can look into those impacts and we can see the impact that our product has on the world. Product again might, for example, in the cotton example again, might use a lot of water. So if there's a lot of water used in the manufacture of a product or in the use of a product, that's an impact that we're going to have is a water use impact. And there are various other examples, kind of ozone depletion if we cause the release of damaging products, and so on. It's these kind of are all kind of negative impacts. Obviously, we can have positive impacts as well, or we can and we can reduce those. We can maximize those positive impacts and reduce these negative impacts as much as we can. But using life cycle assessment is the way to find out what those negative impacts might be. Okay, so the actual process of undertaking life cycle assessment, we'd look across the life cycle scopes of a product. So across from, as you can see in the diagram there, from materials through some sort of processing and manufacturing stages, distribution if we transport a product, through use and through the end of life. You can see all those stages can have an impact. So there are a few common kind of scopes that we might look at. So there's one that's called cradle to gate. So that is talking about starting from our raw materials and going up to the kind of distribution of a product. So the gate refers to kind of a factory gate. So if we think about a product that's manufactured, this is the impact that it has up until when it leaves the factory gate or wherever it's manufactured. So it doesn't include what the user might do with it and what happens at the end of life. We can do what's called cradle to grave, which is from the raw materials up to when the product is manufactured and is finished and is disposed of. So it's kind of grave. It's the death of the product, if you like. So that's that kind of full life cycle. And we can also look at something called cradle to cradle. So if we have a product that can be remanufactured or reused or recycled, we can start to kind of go back round this loop and talk about the product in the whole. So we can talk about going right back to the raw materials again to restart the manufacturing process. So if you look in, I would talk a bit later about kind of looking in literature and stuff about LCA, you'll find certainly cradle to grave and cradle to gate mentioned quite commonly as the kind of two scopes. In terms of actually doing a life cycle assessment, so I won't go into too much detail here, but there's kind of four kind of key steps really. So I'll just talk through those quite quickly. So goal and scope is kind of the first step. So we need to define the goal. We need to look at what the aim of our life cycle assessment is. Do we just want to know what the carbon footprint of something is? Do we want to know what the water use impacts and all those other impacts we just looked at? What do we actually want to know? Define the scopes, as you just said, what life cycle we want to look across. Any comparisons? So life cycle assessment is quite useful to compare one version of a product with another. So it's we can establish those comparisons at the beginning and set our kind of boundaries. And we also define what's called a functional unit. So that's something that allows us to compare products. So it might be a kilowatt of electricity, or in the solar cold room, it's the ability to cool a certain product by a certain temperature. So it's something that allows us to compare similar products without needing to. It kind of removes the impact of the size of the product. So it's not talking about a solar panel, because you could have a big one and a small one. It's talking about a kilowatt of electricity, for example, in that case. The life cycle inventory is a very complicated way of saying basically getting the data that we need. So it's talking about collecting the inputs and outputs that we'll need for our life cycle assessment. The impact assessment, again, is a complicated way of saying actually just doing the assessments. This is if we're talking about particularly in using life cycle assessment software, which we'll talk about in a second. So this is the stage where we actually kind of do the calculation. And then the interpretation is how we kind of look at those results afterwards and how we might present our results. I'll show an example in a minute. You can see that sometimes we can get loads and loads of data out of a life cycle assessment, and it might be too much information, and it's about how we kind of work out what's the important information and get that out and present that well. So those kind of four stages really apply if we're looking at doing life cycle assessment using software, which is something that we might do, but isn't don't necessarily have to, and there are many ways that we can apply life cycle thinking and undertake life cycle assessment without needing to use the software and things, which can be quite expensive and a bit time consuming. But if anybody is particularly interested, there's some kind of examples here of what common softwares. So the two on the left, SimmerPro and OpenLCA, are software that then require the use of a database. So a common database is the EcoInvent one I've got in the middle there. There's also a combined package sort of system called Gabi, which is the one I've shown on the right there, which there are various kind of options that people that are used around the world for doing LCA. I just thought I'd put this on here in case if anybody's looking on the video or anything like that, if you do want to have a go at doing some LCA using the software, there is a way you can do it for free. So the OpenLCA is a free software, and then normally you would pay for a database. So you can download that software for free, and there are also some free databases. So if you follow the tutorials and things on there, you can combine the two, and you can do an LCA for free without needing to buy any software. But really, you can, in order to do an LCA of a product, you don't necessarily need to do your own LCA. So there's a lot of literature out there, and there's a lot of published information that you can use if you kind of understand how life cycle thinking works and understand the scopes and the information that's gone into doing an LCA. You can use information that's already published, and I think this might be what's useful for you guys on the design challenge, is to kind of look at relevant already published information and use that to kind of inform your decisions and help you do some LCA. So I kind of got two kind of main sources of information that might be useful. So there are documents called environmental product declarations. So these are documents produced by, so this is an example of one for a solar panel. So this is produced by the manufacturer, and it basically gives us a simplified LCA for the product. So it tells us a lot of the answers that we'd be looking up if we were running an LCA ourselves. And that you can find those by searching for them. Then they're not available for every product, but they might be for the relevant ones. And there's also academic literature or kind of any sort of published literature. So there's a lot of journal papers, open access journal papers and various journal papers about life cycle assessment. So you can kind of look in a lot of those, and you'll find a lot of information contained within those to allow you to use that information. I think we'll talk in a minute about what you would need to kind of bear in mind when you look at some papers. So we can't just compare any results from any paper side by side. There's a lot of differences between the way those studies were done in terms of the scopes and things that we talked about. So we need to make sure that we're comparing the right thing. So yeah, just some kind of ideas to think about there. Make sure that the scope is the same. So we can't compare a cradle to gate study with a cradle to grave study. So we need to make sure that those results are the same, and we're comparing like with like. Make sure that we're comparing the same functional unit, as we've mentioned about what that would be. And particularly if looking at the location of the study, for example. So a European study isn't always comparable with a study relevant to a Chinese product or likewise or other parts of the world. There's the location of a manufacture or something can be quite significant, particularly if it's something that uses a lot of electricity in its manufacture, because of the differences in grid intensity in different countries. So that can be quite relevant to consider. Okay, so I'm just going to show, this is an example that I mentioned about the results from an LCA study. So this is, I've kind of put this here, this is deliberately complicated to kind of show how much information we can get from an LCA study. So I'll just take a second to kind of explain what we're looking at here. So down the side there, where we've got water use, photochemical, terrestrial, and so on, that's showing us the impacts. So those are the number of impacts that we're looking at in this study. So near the bottom, you'll see climate change. So that's the one that's basically talking about carbon footprint. So that's the one that is often quoted, but you can see there's a lot of other impacts that we've also calculated during this study. And in each of those, you'll see there are 1, 2, 3, 4, 5, 6, 7 different colored bars. So each of those represents a battery type in this case, and you can see them along the top. There's the lithium ion, NCA, and so on. So what this is doing is comparing results for different types of batteries producing the same amount of power and looking at the relative impact of each. So we can see that this is really complicated, and this information is hard to kind of to take in one go, but we can use this to really see. We can see, for example, that these light blue bars very often extend all the way over to 100%. So in most cases, this light blue product, which is the lead acid battery, is performing the least well. And if we look over on the left-hand side, we can see that the shortest bars are often the yellow bars. So we can see in this case that the lithium-ion LFP batteries are quite often the best performing. So this kind of shows us two things. It shows us that we can get loads and loads of information from an LCA study, and that not all of it might be useful, so that we need to kind of be careful that we don't overload ourselves with so much data. But it also shows us that by comparing products side by side, we can see which are the best and which is the worst. So we don't necessarily need to know what the units are for acidification or the units for any of these things. We can just compare our options, and we can use that in we know we're going to need to use a battery, so we can compare all the types of batteries that we could use, and we can essentially pick the least damaging one. It's good in this case that there's one battery that is the best performing in almost every category. So it might be that in another example, we might have one battery, say, or one product that performed well in climate change, but performed badly in another area. So then we would need to decide, what are we most worried about? Are we most worried about land use, or are we most worried about climate change impacts, for example? So there might be a product that has a lower climate change but causes a lot more land use change, and then we would need to kind of weigh up the balance of the two and decide in our design process which is the one we're most concerned about. Okay, so I'm just going to do a quick kind of summary of how we can apply this life cycle thinking, and a few maybe practical examples of how you might things you might think about during your design work. So without necessarily having to do an LCA, we can think about these things and kind of consider whether our product can have a high impact or a low impact. So for example, if we're using raw materials that are difficult to get, essentially, so if they need a lot of refining to get, so if there's lots and lots of stages of processing required to get that material, if there's something that's very scarce that needs a lot of work to get, or if it's a thing that's difficult to find, if it requires a lot of mining, a lot of these products also tend to be expensive for the same reasons. So this is kind of a good indicator if a product is quite expensive. It quite often probably has a high impact. So if we're looking at manufacturing a product and we know that some of our raw materials have a very high impact, we can consider, could we use an alternative product? Could we find another source of that product, or an alternative product that we could use instead? So for example, a waste product from another process, or is there some other way that we could find a similar product? Does something require transport by air? So air transport is particularly high impact way of transporting something. So if we don't need something very quickly, so if it's for example, food products that need to be that waste very quickly, need to be transported by air, otherwise they've gone bad by the time they arrive. But if we're talking about a raw material, it probably doesn't need to be transported by air. So transporting it, taking longer, undertaking the design and the procurement a bit earlier, so that transport can take longer, is a good way to reduce the impact of the same product. Again, does it rely on a resource that's scarce? So for example, if we're using a process that uses a lot of water in a country that has water shortages, that's not a good idea. So if our process needs to use a lot of water, can we do it in a country where there's plenty of water? If we have a process that needs something to grow, that needs a lot of land, then we should do it in somewhere where there's a lot of land and there's not a lot of land conflict, for example, with any other categories. And similarly with energy. So if we have a process that we need to undertake that uses a lot of energy, the way to minimize our impact of that is to do it in a country that has the lowest impact electricity. So do it in a country that has a renewable energy grid, or in a process where in a country where we can use solar power or some other renewable power. Okay, so there's a few things to think about in life cycle assessment and life cycle thinking. So now I'm just going to hopefully quickly talk about a case study. So we'll introduce Victor. So yeah, this is a case study with the company Solar Cooling Engineering, which Victor will introduce in a minute. And we've been working on the net zero cold room with them. So if I just go here, hopefully I can let Victor introduce himself. Okay, so that's an introduction to solar cooling engineering. So now they're gonna talk a little bit about looking at sustainability in solar powered cold rooms. So this is the project that began life here and that has become now the net zero cold room project. So Victor's just going to talk a little bit about from their kind of design point of view, what are the important aspects of sustainability when thinking about a cold room, just to give us some background for this case study. So yeah, Victor was just talking at the end there about considering the use phase of the cold room as well. So we're saying that the cold room allows a reduction in the waste food, which itself has a carbon impact and a greenhouse gas impact saving. So it's a kind of an important consideration whether we include that in our LCA or not. So whether we're looking at making a cold room that is net zero at the time that it's installed, or whether it only becomes net zero over its lifetime as it kind of does its work over its lifetime. So in this case, we're considering those avoided losses, but it's important to, when you consider an LCA, you have to think about would those losses be avoided anyway? So if there's some other reason that they would be avoided, so then we shouldn't really include them in our LCA. We kind of have to consider only the things that our product allows to happen. Okay, so yeah, as Victor said there, we started kind of developing the net zero cold room. So we're working at the moment with solar cooling engineering and architects in Kenya and in Switzerland about designing this cold room. So this is the cold room design as it currently exists on the left there, and you can see this is the current kind of impact that we've come up with for the cold room. So you can see in the slide, hopefully at the top, we have a biogenic storage. So that's talking about materials that are made from timber and bamboo and recycled wood. So they actually, as those products grow, they absorb CO2. So as a plant grows through photosynthesis, it absorbs CO2. So if we then use a wooden product, that CO2 remains stored within the timber. So within all the timber construction used in the product here, that remains captured in there. So you can see that in the green bar at the top there. But also in the manufacturing of those parts, there are some impacts. So you can see the greenhouse gas impacts on the right hand side there. And you can see particularly large at the bottom, the PV, so the solar panels and the batteries have a particularly large impact. We need them to, obviously, for the cold room to operate, but we need to know what their impact is. And we've done quite a lot of work on batteries, comparing different types of batteries. So I think we'll go back to Victor and he can talk a little bit about the batteries and the PV panels. Yeah, so the batteries is an area that we've done quite a lot of work on the LCA. So I'm going to show a few kind of results here from the different types of batteries that we've considered. So these are the same as the types that we looked before. So I just wanted to show here really that depending on what is your main concern, the results might look slightly different. So here we're looking at the greenhouse gas emissions. So this is again the carbon footprint. So we can see that in that case, the lead acid battery has the highest impact, and various other types have kind of lower impacts. But if we look at some other measures, so water consumption, we can see that in water consumption, the worst one is actually this lithium-ion NCA type of battery. So if we're looking to minimize our water consumption and our carbon footprint, then we need to pick one that's low in kind of both of those categories. And again, we can look at lots of other kind of impact. So this is looking at resource use. This is the amount of energy that's used to make and manufacture and transport the thing. So we can see here that, again, the lead acid battery is not particularly good, and some of the lithium ion ones are looking very good. And then finally, that we looked at here, we compared land use. So again, you can see in land use the one of the lead acid batteries and the lithium ion NCA types are not so good. Luckily for us, across all of these, the lithium-ion LFP, so the battery in the middle there, is actually the best performing in all of these indicators. So we didn't have a kind of difficult decision to make here, but quite often in LCA you'll have a result where one performs well in for example this category, but then performs less well in others. And there's the kind of, like I said earlier, that kind of balance of what impacts you're most concerned about to think about. So I think one of the last things Victor's going to talk about next is kind of using LCA as part of the design process for this kind of optimization. So trying to kind of keep looping back through the design process and then going back and looking at the LCA and working the LCA and the design at the same time, as we talked about earlier in that life cycle thinking section. Yeah, so that's getting quite deep into the kind of design process, but it's just talking about how we can kind of use the LCA to compare various things. So we can compare the cost and the performance and the LCA and look at all those three kind of things side by side. So yeah, one of the last things I'm going to talk about is how we've kind of worked with solar cooling engineering on this optimization process. So we've got this kind of LCA tool. So this is just doing LCA as I talked about before, and kind of with information from various sources and from papers and from our own assessments, and we've combined them into this tool, which just allows us to kind of test various options to see what the best options might be. And this just highlights how if we can do this LCA early in the design process and apply that life cycle thinking early, it really gives us so many more options about how we can design the product, and it's really useful. So yeah, again, talking about how we can look at LCA in comparison with various other measures. So this is talking about with batteries again, so we can compare the performance with the cost, the performance in certain weather conditions, and we can compare all those kind of various other variables with the life cycle assessment to get the best kind of overall solution. Okay, so I think we just got a final thing from Victor about the net zero cold room, and then a quick conclusion, and then I'll be finished. So I'll just let Victor finish talking about the net zero cold room. So yeah, if anybody's designing anything relevant, there's a few maybe useful tips from Victor there about kind of considering alternative materials, and also talking about the optimizing the design of the PV and the batteries to help us get as close to net zero as we can. Okay, so finally, just a very quick conclusion. So talking about how you might use life cycle assessment in your design challenge. So I think, applying life cycle thinking, I think, is probably the key. So to try to, as early as you can in the design process, to keep in mind those things we talked about the life cycle thinking, about the whole product at the beginning, how it's going to be used, how it will be disposed of, where you're going to get those materials from, whether you need to use certain materials or whether other more circular or more sustainable materials could be used. So I think I just put quickly at the end, if you only remember 3 things from this, I thought the three most useful things potentially could be, like I said, so consider the life cycle from the start. We sometimes say consider the end at the beginning. So consider how that whole life cycle is going to work right from the beginning. We talked a lot about life cycle assessment and using software and the complexity, and that can be kind of a long process, which you can do, but equally there's a lot of work out there. If you look for it, look in detail at what it's actually talking about, and find the work that is relevant to your needs. But there will be something out there that has probably already done the thing that you need to do, or at least got close. And finally, if we're talking about just having the biggest impact that we can, if you're talking about materials and manufacturing things and stuff like that, avoid flying materials is going to really make a really big difference. So if you can, if you need to use batteries, flying batteries is a really good way to massively increase your impact. So yeah, if you can transport things slowly, you can have a much lower impact very, very easily. So I think that's all I had. Hopefully somebody has some questions. But yeah, I hope that's useful to people, and happy to answer any questions. Thank you.
Thanks very much, Stuart. I think that's some really, really helpful and actionable insights there. I love that. Consider the end at the beginning. Something for me to remember for sure. So let's move on to the Q&A. Hopefully people have come prepared with some questions. So we'd love to hear those from you now, and you can do that by entering them in the chat, by raising your hand, coming off mute. It's nice to see your faces if you're comfortable with that. So I'll open the floor to questions. None coming forward immediately, that's fine. If you have any, please raise your hand, please put them in the chat. I do have a question that I'll ask Stuart now. I'm wondering whether LCA needs to use quantitative data in its analysis, and whether and how it could use qualitative data and integrate that as well.
Yeah, that's a good question. So I think I mentioned at the beginning about how we can look at, we can also use LCA to look at social impacts. So there's a branch of LCA called social LCA, where for kind of social impacts, we don't tend to have any quantitative data there. So that tends to be done entirely with kind of qualitative data. So the way we do that is through kind of expert analysis. So we do that kind of, when I talked about impact, I talked about the sort of the change from the world without your product. So we kind of do those, we kind of use expert interviews and expert analysis to kind of try to consider what those changes would be. So if a product existed, or if something occurred, a part of a process occurred, then what the change would be, for example, in rates of education, or job availability, or other kind of social indicators. There's again, like the environmental indicators, there's a whole range of social indicators. So for all of those, for all that social LCA, we would use qualitative information for that through those kind of expert interviews, and if possible through kind of previous experience of similar situations or similar changes that might have occurred in other locations, for example. So for social LCA, we would use qualitative data a lot. For environmental LCA, the quantitative data is kind of useful for getting the kind of full numerical analysis like we've looked at there. I think I think in terms of kind of life cycle thinking, then the qualitative information is really important overall. So it's kind of the sort of information that people know sort of subconsciously, or that kind of common sense information about kind of when we talked about if something is, if a raw material is very hard to extract or very hard to transport or takes a lot of effort to refine, we probably don't necessarily need to know the amount of energy used in that refinement. But if we know that it's a very difficult, labor intensive, long process, then we probably have a good idea that it's going to be a high impact process. So even without quantitative data in that kind of context, we can have a good idea that what's likely to have a high impact. So yeah, I think in that sense, the qualitative information is useful. I think if we're going to do a kind of numerical life cycle assessment with using software or something like that, for environmental impacts, we would need quantitative data, but for life cycle thinking, certainly not. And that's often all we need, really. We often don't need that full assessment.
Yeah, I think that's really helpful as well for the challenge, to kind of bring that life cycle thinking along with us, even though it's probably not possible to do a full LCA. Thank you.
Sure. Yeah.
Abdulaziz, I see you have your hand raised.
Yes. Good afternoon, Dr. Stuart. Thank you very much for a wonderful presentation. I really learned a thing or two in your presentation, and I would like to ask a question. When designing for humanitarian contest, is it advisable or is it really necessary to consider life cycle assessment? For example, you are designing something for humanitarian contest, and these are things you use on a daily basis, on a regular basis, and maybe you have a limited supply of materials available to you in your locality, and these materials maybe emit little or insignificant amount of greenhouse gases. So is it really necessary? Is it really important to really put in place the life cycle assessment when designing for the interim, before you get better materials or resource to replace the one you've used for the design of the humanitarian product or design per se? So what is your advice on that particular side?
Yeah, I think I think it's a good question. I think in the case you described, then probably doing a full LCA is probably overkill, is probably unnecessary. I think again, like we said a minute ago, I think applying those kind of life cycle thinking principles would be good. So maybe just to kind of have a check, really. So like you said, you're using kind of a limited number of materials and probably local materials, and so in that case, it sounds like those materials, they sound like they're going to be low impact materials. So it's probably good. But I think I would just sort of try to have a quick kind of check, even just in your mind, that those materials are all kind of relatively simple materials, and just try to think of each material, think where does it come from? So how did this material get into the form that it's here in my hand, and what processes have it gone through? And just think to yourself about what those processes would be, and just kind of make sure that you're happy that they're relatively low impact processes. If there's something that is in a form that you don't know how it got into that form, for example, so it looks like it was welded or it was made or forged in a certain way, then, and if you don't know how it got there, then that might be something where you would want to maybe do a small assessment just on that product or just on that material, just to make sure that you understand where everything has come from. But I think in the case you described, you probably have a good understanding of where all those materials have come from. So you're kind of already doing that life cycle assessment in your head when you look at it, to know that those are low impact materials. So I think in that case, yeah, just kind of document that and make sure that you know that. But yeah, I think it would just be, if there's any material that you're not comfortable with knowing where it came from and the route that it's gone through, then maybe worth doing a quick check on that one. I hope that's helpful.
Yeah, thank you, Dr.
Great.
Thanks. Sean?
I just wanted to follow up from your answer to Rachel's question about qualitative assessment, and whether something like whether resources come from like a particularly exploitative industry for the people that extract those resources, whether those get included in LCAs, and what the importance of assessing that is.
Yeah, so it is really important. So that's one of the, so in a conventional only an environmental LCA, that wouldn't necessarily come out. So there's some, there's some kind of indicators that would imply it maybe in an environmental LCA, but only when you get into real depth. So I think that's where the value of doing the environmental and the social LCA really comes in, because you can, so from an, you could have something that, you know, comes from an exploitative industry, or something that you would want to avoid from a kind of, you know, obviously a social moral point of view, but in purely environmental terms, it may not jump out as looking bad. So that's why we need to make sure that it's partly through the selection of the indicators, so selecting those right indicators, and I think probably doing a kind of combined environmental social LCA would be the way there. But I think it's all part of this kind of, a bit like we said in the answer to the last question. So it's about kind of doing that screening process first that we know. So there may be some materials where, you know, we know where they've come from, so we don't need to worry about that. But there may be some materials, if we're unsure of the origin and we know that there's potential that they could come from some exploitative or other kind of area that we would want to avoid, then we would kind of do a social LCA element for those. Or it can even be as simple as the environmental LCA probably tells us geographically where those materials have come from. So then we can do some simple kind of research into that background and say, this material from this country, is it likely to, you know, we may find that there's only one source that it's come from, so we can kind of answer that question immediately ourselves. So so the environmental LCA kind of gives us some kind of tools to look into those areas, but it doesn't answer it fully unless we do the full social LCA. But often it kind of gives us the information that we need to do that next step of research.
Thanks, Stuart. And that's good to think about whether and how we want to integrate that kind of sustainability and environmental and social LCA together. Good points. Thank you. Does anyone else have any questions for Stuart? Feel free to pop them in the chat as well. Chizube, do you have one? I see you come off mute.
Good afternoon, Rachel. Good afternoon, Stuart, right?
Yes.
Sorry, I just joined in and I came late and I missed out in the whole webinar. But I want to ask if I can get this the slides.
Yeah, I think the slides will be available, and I think there's a recording also that you'll be able to watch back.
Oh, lovely. Thank you.
Yeah, they'll be on CrowdSolve, Chizube. So if you go to the events forum and to the post about life cycle assessment, I'll pop those in there later today for you.
Okay, thank you.
You're welcome. Right, so I think we just have time to revisit our question from the beginning. So let me head back to the whiteboard here. Okay, so if we just zoom in on this question at the end. I'm not sure everyone was joined when we did this earlier, so I'll just briefly explain. We have the question for you: do you plan on using life cycle assessment in your challenge project? And some sticky notes at the side that you can drag and drop into the relevant answer that you feel matches where you're at the moment. So we've got yes, no, maybe, undecided. And if you're on a desktop, you can do that by just clicking and dragging the sticky note. If you're on a phone or a tablet, I think you need to click into the sticky note to highlight it and then drag it across. Well, we have a yes. Fantastic. So I'll just give you a few moments more to do that. Also feel free to pop your answers in the chat if you're struggling with the board, or if that's easier. Okay, just one yes. Maybe we're speaking for everyone there. 2 yeses, wonderful. That's what we like to see. Great, so let me head back to the slides. Thanks, everyone. Yeah, that's great to see that this session has like inspired and kind of solidified that that you want to use life cycle assessment. So yeah, thank you very, very much, Stuart. I'm going to move on to design challenge information now, so feel free to drop off if you'd like. But yeah, thanks very much for being here.
Great, thank you. I'll just turn my camera off and yeah, stick around. But yeah, thank you.
Okay, thanks.
Bye.
Okay, so we've done that and that question. So just quickly from me, what's coming up in the challenge soon. So now we would ask you to please sign your terms and conditions and create your project space on CrowdSolve and add all your teammates. And then on the 14th of February, we have the deadline for concept note submission. So we're excited to get those in soon. And yeah, the sooner you get them in, the sooner you can be assigned a mentor and get your concept note review and really get off to a great start. So prioritize that if you're able to. And then coming up soon, you'll be assigned a mentor, as I mentioned. We have prototype funding application window 2 opening on the 5th of February until the 1st of March. Then we have another drop-in for any questions that you have about the challenge on the 15th of Feb. We have a career conversations about scholarships and a couple more webinars, so an early stage business steps webinar and a student's choice webinar. I see somebody has their hand raised.